Hi students, I hope all of you are good health. So today in this video lesson, we will be having a recapitulation of the chapter Language of Chemistry. Now, let us begin with a few question answer session like what is a chemical equation? Now, students, as we all know that while representing a chemical reaction, we always use symbols or formula of the reactants, right? So, a chemical equation is the representation of a chemical reaction using symbols and formula of the reactants involved and the products formed in the reaction. That means chemical equation represents a chemical reaction where the symbols and formula of the reactants involved will be written on the left hand side and the products formed will be written on the right hand side. Again, we have to use the symbols and formula so required. Next is, what is a chemical reaction? Now, any change in matter that involves its transformation into one or more new substances is called a chemical reaction. Like when we are adding sodium to water, what we see? Instantly, sodium catches fire and a new compound is formed which is known as sodium hydroxide, and also the gas hydrogen is liberated in the process. Again, if we take another example, like while formation of the liquid water, we use the gaseous form hydrogen and oxygen. Now in either of the cases, what happens? The characteristics feature of the reactants are entirely different from that of the products formed. Like water is liquid in state and has its own property, while oxygen and hydrogen is a gas which is having a separate characteristics feature. That means any change in matter that involves transformation into one or new substances, means formation of a new substance occurs, then that particular change is known as chemical reaction. Means entirely a new component will be formed at the end of a reaction. Next is another essential feature of chemical reaction is that we need to balance a chemical equation. That means first we need to write the word equation of a chemical reaction. Then we need to write the symbolic representation of the word equation to form a chemical equation. It may also be known as the skeletal equation. Now, after writing the skeletal equation, it is very much essential to balance a chemical equation. But now the thing is how to balance a chemical equation. So what we will do, students? We will follow few ways, but the question is why we need to balance chemical equation. And this is the reason so stated over here is a chemical equation needs to be balanced so as to make the number of atoms of the reactants equal to the number of atoms on the product side. Otherwise, what will happen? It will violate the law of conservation of energy, which states that matter can neither be created nor be destroyed. And since atoms forms the smallest indivisible part of matter. That means atoms can also neither be created nor be destroyed. Rather, what happens during a chemical reaction? There is just a rearrangement of chemical reaction that takes place, and as a result, a rearrangement of atoms takes place, and simply we have to balance the number of atoms on the reactant side with that of the atoms on the product side. The next thing is state 4 conditions necessary for chemical reactions to take place. Now students, I told you many factors are responsible for a chemical reaction to take place, and the few such conditions are stated below. But remember one thing, a particular condition is required for a particular or specific reaction. Means all these conditions are not applicable to each and every reaction. That means all these conditions are not universal. That means for a particular reaction, a particular uh, condition is required. And the conditions in general are close contact. For some chemical reactions to occur, the reactants should be in close contact. Like we already read about sodium, when comes in close contact with water, it instantly catches fire. Similarly, some of the reactants should be mixed in a solution form, otherwise the reaction will not take place. For substances to react with each other, they must be mixed in solution form. Okay, like while the formation of silver chloride, we saw that the reactions were taking place by mixing them in solution form. Next, some reactants need to be heated to undergo a chemical reaction. Like while formation of iron sulfide, that is what were doing is we were simply heating the reactant sodium and sulfide together to form the reddish brown color iron sulfide product. Some reactions require light to take place, and one such example is photosynthesis, which occurs in green parts of the plant which consist of chlorophyll. Okay, while performing the process of photosynthesis and preparing food with liberation of oxygen, the plant trap this light energy which is required for combining this carbon dioxide with water to form glucose and oxygen. Next is some of the reactions require catalyst to speed up the reaction or to slow down the reaction. Like manganese dioxide is one of the catalysts that either speeds up or slows down the chemical reaction. Next, another important and essential concept is the difference between reactant and the product. Some of you all always mistake it. That is why it's one of the important question, like reactants. These are substances that undergo chemical reaction. Like in case of formation of water, hydrogen and oxygen, which is written on the left hand side, is the reactant. And the new product which is formed as a result of the chemical reaction is known as the product. Now, product, these are new substances formed after chemical reaction with change in chemical compositions are called product. Like after formation of water from hydrogen and oxygen, the entire chemical composition of water was different from that of hydrogen and oxygen. Next, we will be learning about how to write a word equation for a particular skeletal equation. Suppose in your exam or you were asked to you will be asked to write down the word equation by seeing this skeletal equation. Like over here in the first case, it is written KClO3. Now K, we know it's potassium, and ClO3, which is a radical, is chlorate. So together KClO3 is known as potassium chlorate. Now potassium chlorate, on heating, it decomposes to give KCl. Again, KCl means K stands for potassium, means K is the symbol for potassium, and Cl for chlorine. Now after forming the compound, KCl will be written as potassium chloride. And O2, it's a diatomic gas, and O is the symbol for oxygen. So we will simply write oxygen over here. If you just look into the arrow which I am depicting, now KClO3, it's potassium chlorate, KCl, KCl is potassium chloride, and oxygen is this one. Next skeletal equation, it is written Zn. Now Zn is the symbol for zinc, and HCl, H stands for hydrogen and Cl for chlorine. Now this together reacts and forms the compound hydrochloric acid. So I have already mentioned in my slide. Then we will put the arrow, as we know that arrow should be, the head of the arrow should be towards which side? Towards product side, and we have to put it in between the reactant side and the product side, and plus sign has to be given to show that which particular compound is reacting with which on the reactant side, and on the product side this plus sign will depict that which product is formed along with which one. Now ZnCl2, this represents the compound zinc chloride. And H2, again H represents the symbol for hydrogen. So H2 is hydrogen. Next one, it is FeCl2. Now Fe refers to iron, and Cl represents chlorine. Now since over here we can see 2 is here, so what does it mean? That since the valency of iron was 2, that is why we have written 2 this below in case of the compound FeCl2. Therefore, we will write the word ferrous over here. Now, since iron is having variable valency, therefore Fe represents ferrous and Cl2 represents chloride. Now, ferrous chloride reacts with Cl2. Cl2 means chlorine. Now, ferrous chloride along with chlorine, it gives FeCl2 according to the skeletal equation. Now again, since 3 is present over here, that means the valency of iron on the product side is 3. Therefore, we will be writing ferric chloride. So I hope all of you have understood that when to write ferrous and when to write ferric. This is a very essential step, students. Don't forget to follow this particular step. Next, another skeletal equation is given over here. Let us see. Carbon monoxide, it reacts with oxygen. Okay. Now, CO. C for carbon and O for oxygen. Since only single O is here, so we will write carbon monoxide. And O2 represents oxygen. Now, it is giving CO2. O2, therefore, we have written dioxide. That means monoxide is written for single oxygen atom and dioxide is written for two oxygen atom. Okay, this is also essential step to be marked. Next is calcium. Ca represents calcium. Okay, and CO2 again carbon dioxide. Together calcium and carbon dioxide gives CaO. Now CaO means Ca for calcium and O for oxygen, but when it is forming the compound, therefore it becomes calcium oxide. This way we are going to write. Next, Na plus O2 gives Na2O. Now Na is the symbol for sodium. So in word equation we have written sodium, and O2 is the symbol for oxygen. Now O2 is a diatomic gas. So simply we have written oxygen. And Na2O. Now again Na is sodium and O is oxygen. But while forming the compound, it will be written as sodium oxide. So this way we are going to represent the skeletal equation or chemical equation in the form of a word equation. Next, let us begin with few more things. Write your observation for the following chemical reaction and name the products. So the first question is, when sugar is heated, what we will observe? Now, as on the right hand side picture, I hope all of you can just follow it. When sugar will be heated, first what happens? It gets broken, it breaks, okay? Break means it, now sugar first breaks and melts and then gets charred into a black residue, which is a new substance called charcoal. Now on the right hand side picture, as you all can see, that sugar, it gets melt and then it forms a blackish substance which is known as charcoal. So this is observed when sugar is heated. Next, when manganese dioxide is added to potassium chlorate and heated, what happens? Manganese dioxide over here acts as a catalyst. It results in decomposition of potassium chlorate and it liberates oxygen. And how we will identify that the gas is oxygen? If you simply bring a burning matchstick in front of the mouth of the test tube, you will see that the matchstick bursts into flame, and this bursting into flame proves that the oxygen is liberated. If carbon dioxide would have been released, then the burning matchstick would have extinguished, because carbon dioxide is a non-supporter of combustion, but oxygen is a supporter of combustion. That is why on decomposition of potassium chlorate, oxygen is liberated. Next one, when dilute acetic acid is poured on baking soda, what will be observed? The right hand side diagram also depicts that a brisk effervescence will be seen. And this is only what written on this particular slide, that when dilute acetic acid reacts with baking soda, it liberates brisk effervescence of carbon dioxide. And this carbon dioxide can be easily detected if we use a little bit of lime water. Then we will see that on passing this particular gas by means of a delivery tube into the uh, lime water of another test tube, we will see that the lime water turns milky. Or even we can bring a burning matchstick near the mouth of this test tube also. We will see that the burning matchstick extinguishes, which shows that the gas so liberated is definitely carbon dioxide. Next, what happens when an aqueous solution of sodium chloride is mixed with an aqueous solution of silver nitrate solution. Now students, this is an example of conditions that is necessary for uh, a reaction, chemical reaction to take place in solution form. As I was saying you that here sodium chloride and silver nitrate will only react with each other when they are in solution form. They will not be reacting in solute state or solid state. So when aqueous solution of sodium chloride is mixed with an aqueous solution of silver nitrate, a white precipitate of silver chloride is formed. As you can see in the right hand side diagram, see, two solutions are being mixed and a white precipitate is formed, which is known as silver chloride. Okay, now silver chloride being insoluble, silver nitrate, a white precipitate of silver chloride will be formed. Why? Because silver chloride is formed when sodium chloride reacts with silver nitrate and it forms an insoluble white precipitate. That is why this precipitate can be seen over here. Next, our next question is when ammonium chloride reacts with sodium hydroxide and heated, and then it is heated. Now when ammonium chloride reacts with sodium hydroxide and it is heated a little bit, a pungent smelling gas with a dense white color vapor, as on the right hand side diagram you can see a vapor of white dense color is emitting and it is having a pungent smell. Even if you inhale it, it's so corrosive that your internal nasal lining may be corroded and even you may feel a sensation of having itchy feeling as well as having a burning sensation is the in the nose. Now this gas is known as ammonia. So when the final thing is when ammonium chloride reacts with sodium hydroxide, a gas ammonia is evolved that has a pungent smell. Next observation. What happens when water is added to quicklime? Now when water is added to quicklime, as you can see in the right hand side picture, that water vapor is coming out. Now how this water vapor can come out? It shows that definitely while adding water to calcium hydroxide, that is quicklime, it will evolve heat energy. And this heat energy will be utilized to convert this water into water vapor. Thus, our observation is when water is added to quicklime, a large amount of heat energy is liberated and which can be felt if you put your hand on this particular beaker. Now our next recapitulation. We have in our previous slides we have learned how to write the word equation by seeing a skeletal equation. Now we will be learning how to write the symbolic representation of a chemical equation but just by just seeing this particular word equation. Now in the first case it is written sodium carbonate reacts with hydrochloric acid. Now sodium carbonate, what is the formula of that? It is sodium is Na and carbonate is CO3. Now since sodium is having valency 1 and carbonate is having valency 1, so we simply wrote this compound NaCO3. And hydrochloric acid, the symbol is hydrogen, the symbol is H, and chlorine, the symbol is Cl. So the formula becomes HCl, and it gives the product sodium chloride, that is NaCl, along with water, that is H2O, and carbon dioxide, that is CO2. So this is the entire skeletal equation which we have got. Okay, now this is not the balanced one. It is simply the representation of the uh, a chemical equation in the form of symbolic representation. Next, we have barium chloride. Now, barium chloride. Now, for barium, the symbol is Ba, and for chloride, it is, that means chlorine, it is Cl2. Now, since barium has a valency 2 and chlorine has a valency 1, so the formula becomes BaCl2. And sodium sulfite, now sodium is Na and sulfate is a radical, it is SO4, and the valency of sulfate is 2 and valency of sodium is 1. So the formula becomes Na2SO4. Next, we have barium sulfate. Now, barium sulfate again, the symbol for barium is Ba, and the formula for the radical sulfate is SO4. Now, when we are making or forming the compound and representing it, we get BaSO4. Why? Since both are having the valency 2, therefore, simply we will write BaSO4. Next, sodium chloride. Sodium chloride, the symbol for sodium is Na and chloride is Cl. Now, when sodium chloride is formed, since both the valency is 1, so it forms NaCl. Next, it's iron to chloride. When reacts with hydrochloric acid, it forms iron 3 chloride. Okay, how to represent this? Now, iron to chloride means valency of iron is 2. Now, in this case, the compound can both be written as ferrous chloride, or it may also be written as iron 2 chloride. So, the formula will become iron, the symbol is Fe, and chlorine, the symbol is Cl. But since valency of iron over here is 2, so we will write FeCl2. And chlorine is having valency 1, so we will not be including over here. So the formula is FeCl2. And hydrochloric acid, the formula is HCl. And then we get iron 3 chloride. Now iron again, the symbol is Fe, and chloride it is Cl. And since the valency is 3, therefore the entire compound becomes FeCl3. Then the next compound is calcium carbonate. Now calcium carbonate on decomposition gives calcium oxide and carbon dioxide. Decomposition means on heating, it splits into these two compounds. Now let us begin. Calcium, the symbol is Ca, and carbonate, the formula is CO3. Now since both calcium and carbonate is having the valency 2, therefore the compound becomes CaCO3. And again for calcium oxide, the symbol for calcium is Ca and oxide is O. Again both are having valency 2, so the formula becomes CaO. And for carbon dioxide we know it is CO2. So the entire skeletal equation represents the word equation, so asked over here. Next, silver bromide. Now the symbol for silver is Ag. Ag is the Latin term from where this symbol is derived, and bromine is Br. The symbol Br represents bromine. Now both are having valency 1 over here, so we are getting AgBr, and on splitting AgBr, we are simply getting silver plus bromine. Now silver is Ag, which represents the symbol for silver, and Br, which represents the symbol for bromine. So I hope students you have understood today's lesson about how to write a simple skeletal equation if a word equation is given, how to write a word equation if a skeletal equation is given, or vice versa. Even we understood how to explain our observation when it will be asked that if a particular reactants react with a particular reactant again, then it will be forming a particular product which will be depicted as an observation. Now, how to record and write so? We have understood today, I have explained you today. So go through the video lesson to learn more. And if you have any doubt, any queries, ask me in our next Google Meet session. Thank you, students. Have a nice day.